Hello viewers, welcome to the lecture series of SSC Quantitative Aptitude. This is your tutor Keshav Agarwal and this is lecture on fundamental arithmetic operations and BODMAS. So this lecture is about solving problems on this topic. So in this lecture we are going to see 25 questions based on fundamental arithmetic operation and BODMAS. So let us start with the first question. A teacher wants to arrange his students in an equal number of rows and columns. If there are 1369 students, then find the number of rows, find the number of students in last row. So if the teacher wants to arrange in equal rows and columns, then we will use the square, and 1369 is nothing but 37 square. Okay, so it means there will be 37 rows and 37 columns. That's exactly what we wanted. The number of rows and number of columns to be same, and each row will have 37 students. Therefore, the last row will have 37 students. So the correct answer here is option number A. Let us move ahead to question number 2. What is the value of 203 plus 107 whole square minus 203 minus 107 whole square? So here we are going to use a formula that says a plus b whole square minus a minus b whole square is equal to 4ab. So in this question, a is equal to 203 and b is given to be 107. So using this formula, so it will be equal to 4 times of 203 and times of 107. And on simplification, you will get 86884. So the correct option here is option number B. The sum of square of 3 consecutive positive numbers is 365. Then what will be the sum of the numbers? So let us suppose the 3 consecutive numbers be x minus 1, x and x plus 1. So it is given that the sum of squares is 365. That means x minus 1 whole square plus x plus 1 whole square is equal to 365. So let us expand the whole square. So it will be x square minus 2x plus 1. X square remains as it is, and this will give us x square plus 2x plus 1, and 365 is in the equal. So you can see we have 3x square and 2x and minus 2x get cancelled, and it will be 2 left, so which is equal to 365. Send 2 to the right hand side and it will be 363. And now x square equal to 121, that means x is equal to 11. So then x minus 1 is equal to 10 and x plus 1 is equal to 12. Since all three numbers are known, now we can take the sum, which is equal to 10 plus 11 plus 12, that is equal to 33. The correct option here is option number B. Now let us move to question number 4. So here we are given 1 minus 127 upon 343 to the power whole to the power 1 upon 3. This is given to us and we are asked to simplify this. So what is it equal to? So that is what we want to find out. So according to question, this is given to us. Let us now multiply 343 this side, and it will be 343 minus 127 upon 343. And 216 upon 343. And if you see, 216 is obtained by cubing 6 and 343 is obtained by multiplying 7 3 times. So we will get 6 upon 7. Correct? So the correct answer here is 1 minus 1 upon 7. So the answer correct here will be option number B. Let us move to next question, question number 5. If 3a plus 4b upon 3c plus 4d is equal to 3a minus 4b upon 3c minus 4d. Then what can be said about the relation between ABCD? So let us do cross multiplication and send this to this and send this to this. So it will be 9ac minus 12ad plus 12bc minus 16bd equal 9ac plus 12ad minus 12bc minus 16bd. And if you simplify, you will get ad equal to bc. So the correct option here will be option number B. Let us now move to next problem, question number 6. If 1 upon a plus 1 upon b plus 1 upon c minus 2 by 5 is equal to 45 by 53, where a, b and c are positive integers, then what is the value of 4a minus b plus 3c? So in this question, this expression is given to us, okay? And let us first of all take 45 upon 53, okay? So we can write 53 upon 45 equal to 1 plus 8 upon 45, and further changes we can write it as 8 upon a equal to, and 45 upon 8 can be written as 5 plus 5 upon 8, and 8 upon 5 can be written as 2 minus 2 upon 5. So if you observe here that a is equal to 1, b is equal to 5 and c is equal to 2, correct? So 4a minus b plus 3c is going to be 4 times 1 minus 5 plus 3 into 2. So it will be 5. So the correct option here is option number C. Let us now move to question number 8. The sum of three consecutive natural numbers divisible by 3 and 45, 3 is 45. Find the smallest number. So let three consecutive natural number is divisible by is x, x plus 3 and x plus 6. So the sum is equal to 45, which is given to us. So it will be 3x plus 9 equal to 45. So 3x will be obtained as 12. So the smallest number is 12. So the correct option here will be option number A. The greatest of two numbers whose product is 900 and sum exceeds their difference by 30 is. Let two numbers are x and y, where x greater than y. So x plus y minus x minus y is equal to 30. So 2y equal to 30, that means y is 15. So xy is equal to 900. So that means x equal to 900 upon 15. That means x equal to 60. So therefore the correct option here is option number A. Let us now move to next question, that is question number 10. The sum of three positive numbers is 18 and their product is 162. If the sum of two numbers is equal to the third, then the sum of squares of number is. Let there are three numbers a, b and c. This implies that a plus b plus c is equal to 18 and a plus b is equal to c. Okay, so 2c is equal to 18. This implies that c equal to 9. That means a plus b is equal to 9. And it is also given that a plus b, abc is equal to 162. So ab times 9 is equal to 162 because c is already computed by us. So ab is equal to 18. And as we know, a plus b whole square minus a minus b whole square equal to 4ab. And substitute the values. 81 minus a minus b whole square equal to 4 into 18. So on simplification, you will get a minus b equal to 3. So now add equation 1 and 2, you will get a equal to 6. So a plus b plus c equal to 18. So 6 plus b plus 9 is equal to 18. So that means b is equal to 3. So now a square plus b square plus c square is going to be 36 plus 9 plus 81. Because we have already computed values of a, b, c, we can just substitute them and obtain the sum, which is equal to 126. So the correct answer here is option number C. Let us now move to next question, that is question number 11. If a equal to minus 12, b equal to minus 6 and c equal to 18, then what is the value of 2abc upon 9? So 2abc upon 9 can be easily computed because a, b and c is already given to us. You have to just substitute the values and it will be 2 times of minus 12 minus 6 times minus 18 upon 9, that is equal to 288. So the correct answer here is option number B. Let us now move to next question, that is question number 12. The value of m minus n times m square plus n square minus m minus n whole cube upon m square n minus mn square is. M minus n can be taken out common from the numerator and we will be left with m square plus n square minus m minus n whole square upon, and mn can also be taken out common from this, that will be mn times of m minus n. So m minus n and m minus n get cancelled, so it will be m square plus n square minus, and we are expanding this whole square and it is equal to minus m square minus n square plus 2mn. So and this get cancelled, so you will be left with 2mn upon mn, which is equal to 2, because mn and mn also get cancelled here. So the correct option here is option number C. Find the value of a in the following equation. So if here it is given that a is less than 10 and the equation is also given to us. So in this equation, let us first send this to the left right hand side, and you will have 11a minus 9 equal to 64 minus 63 plus a square. Okay, and on simplification, just little bit moving the stuff, it will be a square minus 11a plus 10 equal to 0. And doing the middle term split here, you will have a minus 10 times a minus 1 and it is equal to 0. That means a equal to 1 and 10. But it is given in the question that a is less than 10. So that means a equal to 1 is the correct answer and hence option B is correct. Find the simplest value of 6.25 minus 1.96 upon 1.1. So 6.25 can be written as 2.5 whole square and 1.96 can be written as 1.4 whole square. Okay, so now this is a square minus b square, and applying formula a minus b, a plus b, you will get 1.1 into 3.9 upon 1.1. So 1.1, 1.1 get cancelled and it is equal to 3.9. So the correct option here is option number B. Determine the missing figure denoted by question mark in the following equation. So here we have equation 15 of 3 of 5s into question mark upon 3 equal to 26. So we have to find this missing value. So 15 of 3 upon 5 times question mark upon 3 equal to 26. 78 upon 5 into question mark upon 3 equal to 26. So on simplification, you will get question mark equal to 5. Okay. So the correct answer here is option number A. The value of 16 minus 0.002 upon 8 plus 0.4 upon 8 plus 0.4 plus 0.02. So here 0.002 can be written as 2 upon 1000, and we multiply 1000 to 16, and 1000 is also multiplied to the denominator. So we'll get 16,000 minus 2 upon 8,000 plus 400 plus 20. So on simplification, just doing some addition and subtraction, and you will get 15098 upon 8420, and when you divide it, you will get 1.9. So the correct answer here will be option number D. Find the value of root 3, root 3, root 3, root 3, and it goes on till infinity. So in this question, we are going to do squaring both sides first. So we will be left with x square equal to 3 under root x under root x under root x under root x and till infinity. So if you see closely, this right hand side is nothing but x again. So we can write x square equal to 3x, correct? So x square minus 3x equal to 0. X times x minus 3 equal to 0. That means x equal to 0 or x minus 3 equal to 0. But x equal to 0 is not possible. So hence we will get x equal to 3. So the correct answer here is option number A. Again, we have similar stuff here, but this time it's not infinite, it's finite roots. So it's root 7, root 7, root 7, root 7, and 4 roots are here. So in this type of series, if the natural number of terms containing some specific value, then we use the formula n to the power 2 to the power t minus 1 upon 2 to the power t, where n given number equal to 7, t number of terms equal to 4, and if you put all of these stuff in the formula, you will get 7 to the power 15 upon 16, that is option number B. Find the value of root 6 plus root 6 plus root 6, and it goes on till infinity. So in this type of question, we do the consecutive factor of given terms. If the series contains positive terms, then the larger factor would be the answer. And if the series contains negative terms, then the smaller factor would be the answer. So consecutive factors of 6 is equal to 2 and 3. And series contains positive terms and the larger factor is 3. So this would be the sum of this series. So the correct option here is option number C. Find the value of root 12 minus root 12 minus root 12, and it goes on till infinity. So again, now recall that what we have studied in the last slide. So in this type of question, we do the consecutive factors of the given number. If the series contains positive term, then the larger factor would be the answer. And if the series contains negative terms, then the smaller factor would be the answer. So by using this method, you can get the sum or this value of this series very quickly. So 12 is equal to 3 times 4, and this, since the terms are negative factor here, so the factor, small factor would be 3. So the answer is option number D. Find the value of root 5 plus root 5 plus root 5 till infinity. Here 5 is the prime number, hence does not contain consecutive factors. So in such question, we use the formula when positive sign contains the series. So it is equal to root 5n 4n plus 1 upon 2, where n is the given number, n is equal to 5. So put n equal to 5 in this formula, you will get under root 21 plus 1 upon 2. So the correct answer here is option number A. Find the value of root 7 minus root 7 minus root 7, and it goes on till infinity. So again, 7 is a prime number and hence does not contain any consecutive factors. So in such type of questions, we use the formula when negative signs contains the series. So under root 4n plus 1 minus 1 upon 2, this is the formula that we are going to use. And here n is equal to 7. So just substitute the value of n and you will get under root 29 minus 1 upon 2. So the correct answer here will be option number D. Find the number whose square is equal to the difference of square of 75.15 and 60.12. So let us suppose the number be x. So according to the question, x square is equal to 75.15 whole square minus 60.12 whole square. So x square is equal to 75.15 plus 60.12 times, so 75.15 minus 60.12. So here we have used a minus b, a plus b identity here. So x square is equal to 135.27 into 15.04, which is equal to x equal to 45.09. So the correct answer will be option number C. Let us move to question number 24. Find the number whose square is equal to difference between the square of 975 and 585. Let the number be x. According to question, x square is equal to 975 whole square minus 585 whole square. Okay, so this is a square minus b square equal to a minus b into a plus b, and a is 975 and b is 585. So this will be 975 plus 585 and times of 975 minus 585. So we will get 1560 times of 390, and if you simplify, you will get 60840, which is equal to 780 square. So x is equal to 780. So the correct answer here will be option number A. Moving on to our last problem of this lecture, question number 25. The difference of two numbers is 1564. After dividing the larger number by smaller number, we get 6 as quotient and 19 as remainder. What is the smaller number? So let the two numbers is equal to a and b, where a greater than b. A minus b equal to 1564, and this is the first equation, and 6b plus 19 equal to a, and a minus 6b equal to 19, that is equation number 2. So we have two equations, two variables, so we can solve both the equation to obtain exact value of a and b. So when we do that, we get b equal to 309, and therefore the smaller number is 309, because it is already given that a is greater than b. So we don't have to go for finding the value of a, we can directly just find the value of b. So the correct option here will be option number D. So that would be all for this lecture. Try to solve all the questions by your own. Thank you very much.